Good evening everyone and welcome to another lecture of engineering mechanics. This is lecture number 7 of engineering mechanics, and in this lecture we are going to study about the equilibrium of rigid bodies. But before we start, let's revise whatever we have learned yesterday. So yesterday we saw the concept of free body diagrams. What are free body diagrams? Free body diagrams are the sketch of a system which can consist of a body, part of a body, or interconnected bodies, isolated from all the other bodies. And when you isolate this body from other bodies, you show the interaction between these bodies through forces. So basically, if you want to analyze the forces of a body, then you isolate that body from all the other bodies. Whatever connection they have, you disconnect them, you isolate the body, and when you disconnect the body from other bodies, you need to show the connection between them, the interaction between them through forces. We saw some good examples of free body diagrams yesterday, and I told you about the reactions due to each type of support. There are three categories of support: roller or frictionless surface, hinge support or friction surface, and fixed support, right? In case of the first category, means roller support, you get one reaction which is normal to the surface of the roller. Yes, same goes with the friction surface also, frictionless surface also. You get one normal force perpendicular to the surface. In case of hinge support, also known as pin support, you get two reactions. But in some cases, instead of drawing these two reactions, we show the resultant of both and we only get a single reaction. Same goes with friction surface also. At the point of contact, you get two forces, right? Like this. And the last one was the fixed support. In this case, you get three reactions. One in X, one in Y, and you also get a couple. Why are you getting a couple here? Why not couple in other cases? Because you get a couple if the constraint is, if the rotation of the body is also constrained. And here, as the body is fixed, the rotation of the body is constrained, so you are getting a couple. In other cases, the rotation is not constrained, so you were not getting a couple. So these were the three categories of supports. So whatever type of support the body has in real life, when we solve the problem in engineering mechanics, we will consider either one of these three supports. And now in today's class, we are going to start with equilibrium. See, the entire statics part is based on the concept of equilibrium. Okay, so we need to first understand what do we mean by equilibrium. So let's understand about equilibrium. See, you might have heard this term in different subjects because equilibrium in different context has different meaning. For example, when you study thermodynamics, then there is a term called thermal equilibrium, right? What do we mean by thermal equilibrium? If the temperature of the two bodies is exactly same, there is no heat interaction between the two bodies, we call them to be in thermal equilibrium, right? Then in chemistry, you might have heard about chemical equilibrium. When there is no reaction happening, you call the chemicals to be in chemical equilibrium. So there are different types of equilibrium. But here we are going to talk about mechanical equilibrium. Here we are going to talk about the equilibrium in the context of forces. So when a body is subjected to different forces, moments, then what will be the condition of equilibrium? When do we say that the body is in equilibrium? In general, you can say equilibrium means equality, because the term itself is derived from this word only, right? Equality, equal. So what does this mean? When all the forces acting on the body becomes equal, they are going to cancel each other. and the net force will become 0. This is a very generalized statement. Exactly in technical statement, if I have to tell you what is equilibrium, mechanical equilibrium, equilibrium related to forces, then a body is said to be in equilibrium if the resultant of the force system is 0. See, the body is subjected to multiple forces, 3, 4, 5, maybe 10 forces. All these forces collectively are known as force system, and this force system will have a resultant. We have already seen how to find resultant of different force systems, right? Now, if this resultant is 0, it means the body is in equilibrium. Now, the resultant can be a single force or a force and a couple. We have seen in some cases we get a couple also. Apart from the force, we also get a couple, right? So, if the resultant is only a force, then that force will be 0 if the body is in equilibrium. And if the resultant consists of the force as well as the couple, then both will be 0. Look at this. Equilibrium means both the resultant force and the resultant couple are 0. So let's say we have a body which is subjected to three-dimensional forces. Okay, this body is subjected to what? Three-dimensional forces. Right now I can't show you the third dimension. Just assume that this body is subjected to three-dimensional forces as well as couples. Now the resultant is 0, right? The resultant force and the couple are 0. So if the resultant force is 0, it means the component of the forces, the component of the resultants will also be 0. So it means summation of fx will be 0, summation of fy will be 0, as well as summation of fz will be 0. See, the resultant force is also three-dimensional. I am assuming right now that the body is subjected to three-dimensional forces. So the resultant will also be three-dimensional. Yes. So it will have three different components. So if I resolve the resultant, I will get three components: summation of fx, summation of fy, summation of fz. And if the resultant itself is 0, the components will also be 0. Similarly, if I resolve the couple also, I will get three components of couple: summation of mx, summation of my, summation of mz. So these are also equal to 0. So we have these 6 mathematical relations. These mathematical relations collectively are known as equilibrium equations. What do we mean by equilibrium equations? Understand, very important. Equilibrium equations are the necessary conditions to be fulfilled if the body is in equilibrium. If the body is in equilibrium, it means these 6 equations must be satisfied. If any one of these equations are not satisfied, the body will not be in equilibrium. So these are the necessary conditions which must be satisfied. Now, why are we studying about equilibrium equation? Okay, these equations must be satisfied. But what we will get by satisfying them? If we already know that a body is in equilibrium, why will we write these equations? Understand this. These equations, these mathematical equations are used to calculate the unknown forces acting on a body. When you draw the free body diagram of a body, there are some forces that are known to you. For example, weight of the body. That is known to you. Okay. But there are some forces which are unknown to you. For example, reaction forces due to supports. This is not known to you. This is an unknown force. So whenever you draw free body diagram of a body, there are some forces that are known and there are some forces that are unknown. These unknown forces have to be calculated. Then only you will be able to design the body, right? In order to calculate these unknown forces, we will use these mathematical equations. So these mathematical equations are used to calculate the unknown forces acting on a body. So what we are going to do is, whenever you have a question where the body is in equilibrium and you have to calculate some unknown forces, you will draw the free body diagram of the body first, because without drawing the free body diagram, we will not be able to apply these equations. Okay, in order to apply these equations, you have to have the free body diagram. Okay, what is this? This is free body diagram. So we can only apply equilibrium equations on free body diagram. Suppose a body is supported by different types of supports. Okay, without removing those supports and without showing all the forces acting on the body, you cannot use this equation. So in order to apply these equations, you have to remove all the supports, you have to isolate the body completely from other bodies, and then only you will be able to apply these equations. Now here, how many equilibrium equations do we have? We have 6 equilibrium equations, right? So how many unknowns we will be able to calculate? We will be able to calculate 6 unknowns. We can only apply these 6 equations, right? So we will only be able to find 6 unknowns. Okay, now understand this. Here I am considering 3-dimensional force system, but you are not going to get 3-dimensional force system in your syllabus. In your syllabus, you deal with coplanar forces. So if there is a coplanar force system, all the forces are going to be in a single plane. Let's say that all the forces are in XY plane. Okay, let's say all the forces are in XY plane. Let's say this is the body. It is subjected to forces lying only in XY plane. Okay, so now if you resolve the resultant, it will only have X and Y component, it will not have the Z component. So you will get only summation of Fx equal to 0 and summation of Fy equal to 0. There is no force in the Z direction, right? So you will only have summation of Fx equals to 0 and summation of Fy equal to 0. All the forces in Z direction are already 0. So you don't need to satisfy this equation, it is already satisfied. Okay, if you apply this equation for this case, you will get 0 equal to 0. So how will you use that? It's a useless equation for you, right? Now if the forces are in this plane, XY plane, they will only be able to rotate the body about Z direction. They will only be able to apply the moment about Z direction, right? This force can apply moment only like this or like this, means about Z direction. It cannot apply moment about X direction. Can it rotate the body like this? Can it rotate the body like this? No. Can it rotate the body about Y axis like this? No. It can only rotate the body like this, about Z axis. So net moment about X and Y are already 0 because they cannot apply the moment about X or Y. They can only apply moment about z. So you will only have this equation, summation of mz equal to 0. So now how many equations do we have? We have 3 equilibrium equations for a coplanar force system. This is the only force system that we are going to deal with in our syllabus. We are not going to deal with 3-dimensional force system, okay? So whenever we will solve problems, we will only use these equations, summation of fx equals to 0, summation of fy equal to 0, and summation of mz equal to 0. So what will be the steps to solve the problem? You will draw the free body diagram of the body. Whatever the body is in the question, you will draw the free body diagram of that body. Then you will apply these equations, you will solve the equations, and you will find the unknown force. What are the unknown forces? Reaction forces. Whatever the reactions the body is getting from supports, those are the unknown forces, okay? So you will draw the FBD, you will find, apply the equilibrium equation, solve the equilibrium equation, and find the reactions. Now whenever you will draw the free body diagram, you will have to see what type of reactions you are going to get. So we have already seen what type of reactions do we have, right? In case of roller support, hinge support, fixed support. Now whenever you are confused about the direction, see, you have to know whether the force will be in x or y. But let's say you know that the force is in x, but you don't know whether it will be towards right or towards left. You assume any one direction. Let's say I have assumed the force to be towards right, to be in the positive x. If I am getting a positive answer by solving these equations, my assumption is correct. And if I am getting a negative answer, my assumption is wrong. I hope this point is clear to you. Whenever you are applying the reaction forces or reaction couple, you don't need to worry about the plus or minus direction. Plus x or minus x, plus y or minus y, clockwise couple or anti-clockwise couple. You don't need to worry about this. Assume any one direction. If you are getting positive answers by solving these equations, your directions are correct. If you are getting negative answers, your directions are wrong. But you can't do this. If a force is in x direction and you are assuming y direction, then you will have wrong answer, okay? So you can't do this. You can't do that. I don't know whether the force is in x or y, I will just imagine. You can't do that. You have to know whether the force is in x or y or in both directions. But positive x, negative x, or positive y, negative y, or clockwise couple, anti-clockwise couple, that you don't need to worry about, okay? I hope this point is clear. Now, equilibriums are of two types, static equilibrium and dynamic equilibrium. Understand the meaning of both types of equilibrium, okay? Because it makes confusion, it creates confusion. Static equilibrium means the body is at rest. Okay. For example, let's consider any one member of the structure you are living in, the house you are living in, beam or column or bar, whatever structural member you consider. That member is in static equilibrium because it is at rest. It is not moving. Yes. What is dynamic equilibrium? Dynamic means moving. So the body is moving. If the body is moving, how come it is in equilibrium? Equilibrium doesn't only mean that the body has to be at rest. Even if the body is moving, it can be in equilibrium. How? Equilibrium means the net force and moment must be zero. Yes? Let's say you have pushed a body and then you have left it. You have given a body a push and then you have left it. And now the body is moving and there is no force acting on the body. Assume the condition, okay? Even friction forces are also zero. Imagine friction force is also not there. You have pushed a body, the body is moving, and now there is no force acting on the body. Even the friction force is also 0. So net force is 0. Now the body is moving. So if the net force on the body is moving, it will not accelerate. It means it will move with constant velocity in the same direction. If let's say the body is moving at 10 km/h in x direction, it will keep on moving in x direction with 10 km/h. It will not accelerate. So net force is 0. So there will be no acceleration, there will be no change in velocity, but the body can move with constant velocity in the same direction. So dynamic equilibrium means body is moving with constant velocity in the same direction. Okay, acceleration is 0. Okay, so understand about dynamic equilibrium. Even if the body is moving, but it is moving with constant velocity in same direction, it means it is in dynamic equilibrium. The acceleration of the body is 0. So you can have static equilibrium, you can also have dynamic equilibrium. In both cases, these equations are applicable. Equilibrium means equilibrium. Net force and moment must be 0, whether it is static or dynamic. Okay? Chalo. Now, let's say you have a question. You draw the free body diagram of the body. There are 3 reactions which are unknown, and you have 3 equilibrium equations. So by applying these 3 equilibrium equations, you can find out the 3 unknown forces. Okay? These type of problems where the number of equilibrium equations are equal to the number of unknown forces are known as statically determinate problems or statically determinate system. What do we mean by statically determinate system? Number of unknown forces or couple. I will not write forces and couple or couple. Assume. So number of unknown forces are equal to number of equilibrium equations. So if I can find all the unknown forces just by using equilibrium equations, it is known as a statically determinate system. Understand the meaning of this sentence, na? Statically determinate. Determinate means I can determine. Statically means by applying static equilibrium equations. So if I can determine the unknowns just by static equilibrium equations, this is known as a statically determinate system. But if the number of unknowns are more, if the number of unknowns are more than the number of equilibrium equations, then what? If the number of unknowns are greater than the number of equilibrium equations, you will not be able to find all the unknowns. So these type of problems are known as statically indeterminate problems. So how are we going to solve these problems? For solving these problems, we have different type of equations, and these problems cannot be solved in this subject. For solving these problems, we have to study strength of materials. When you will study strength of materials, you solve statically indeterminate problems. Okay. So in engineering mechanics, we only deal with statically determinate problems. We do not deal with statically indeterminate problems. So whenever you find a question of engineering mechanics. It has to be statically determinate only. Okay. Indeterminate problems are solved in strength of materials. Chalo. So let's start solving problems. We have all the concepts we need to solve the problem. Let's apply these concepts and let's solve problems. But before getting into that, we have some interesting cases of equilibrium. Okay. So let's first find out these cases. The first case is equilibrium of a two-force system. Now, what do we mean by equilibrium of a two-force system? Understand the meaning of this. If a body is subjected to two forces, only two forces, okay, there is no third force. If a body is subjected to two forces and it is in equilibrium, it says that the forces must have the same magnitude, same line of action and opposite direction. Wait a minute, okay. I'm so sorry, there was an emergency. I have to take a pause. Sorry for that. I'm back. Okay. So we were discussing this first interesting case. Although it's not a very big case and you will not find questions from this case because this is a very easy problem. If a body is subjected to only two forces, then according to this case, the forces must have the same magnitude, the same line of action and opposite direction. Means, let's say there is one force like this. Okay, and the body is subjected to only two forces. It means that the second force must be acting like this only. And if this force is F, this must also be equal to F. So they should have the same line of action, same magnitude and opposite direction. Let's say one force is acting like this and another force is acting like this. Can the body be in equilibrium? Let's say both are equal and opposite, but their line of action is different. Can they be in equilibrium? No. They will form a couple. The body will start rotating. So this cannot happen. If the body is subjected to only two forces and the body is in equilibrium, then the two forces must be equal, opposite and should have the same line of action. Okay. Now you will not get questions from this case because it will be very easy, right? Now this case is very, very important. Equilibrium of three forces. Let me tell you, you will find lots of questions based on this concept. Okay. So understand this concept. If a body is subjected to three forces and it is in equilibrium, then the three forces must be coplanar, parallel or concurrent. It means if the body is in equilibrium, let's say this is our body, okay, let's say this is our body, then according to this statement, the forces must be coplanar. First of all, they should be lying in the same plane. They cannot be in different planes. If there are only three forces, they must be coplanar. Second thing, they should either be parallel like this or concurrent like this. They cannot be like this. So this is possible, this is possible, this is not possible. And this is a very interesting concept. Okay, we are going to use this concept in questions. If a body is subjected to only three forces and the body is in equilibrium, the forces must be coplanar and they should be either parallel to each other or concurrent to each other. They cannot be like this. Two forces are parallel and third force is like this. This cannot happen. Okay. Now, if you get this case, then you have a very interesting theorem known as Lamys Theorem. Now, what do we mean by Lamys Theorem? Understand, it's a very useful theorem. So let's say that a body is subjected to only three forces like this. One force is like this, other force is like this. If you extend their line of action, they will intersect. The third force is like this. Let's say this is F1, this is F2, this is F3. Okay. Let's say the angle between F2 and F3 is θ1. The angle between F1 and F3 is θ2, and the angle between F1 and F2 is θ3. Understand how I am taking the angles. The angle between 2 and 3 is 1. The angle between 1 and 3 is 2. The angle between 1 and 2 is 3. Now, according to Lamys theorem, F1 divided by sine θ1 will be equal to F2 divided by sine θ2 will be equal to F3 divided by sine θ3. This is also known as sine rule. Okay. And this is a very useful theorem whenever you have a situation like this. Okay. F1 divided by sine θ1 will be equal to F2 divided by sine θ2 will be equal to F3 divided by sine θ3. Now, if you want to use this equation, you should know all these angles θ1, θ2, θ3, and you should know at least one of these forces. Okay. In order to use Lamys theorem to find the unknown forces, at least one force must be known and all three angles must be known. Okay. Then only you can use this theorem to find other two forces. For example, let's say we know F2. Let's say we know F2 and we know θ1, θ2, θ3. Now in order to find F1, I will use this equation. F1 by sin theta 1 equal to F2 by sin theta 2. And in order to calculate F3, I will use this equation. F2 by sin theta 2 equal to F3 by sin theta 3. So at least one force must be known and all three angles must be known. Okay. And whenever you are drawing this diagram, in order to calculate the angles, you need to either draw all the forces like this coming out of this point or going towards the point like this. You cannot draw two forces towards outside and one forces towards this. Then if you calculate the angles, it will give you wrong answer. Okay. Chalo. So let's solve some problems, and this is our first problem. A plate is subjected to coplanar forces as shown in figure. It is supported at A and B. Find reactions at A and B in Newton. It's a simple problem. What is happening here? We have a plate which is subjected to coplanar forces. The plate is roller supported at A. Can you see the rollers? So here at point A we have a roller support, and it is a hinge, it has a hinge support at B. Can you see this hinge? And now we need to find reactions at A and B. So let's solve this problem. Now first thing you need to do is you need to draw the free body diagram. How to draw the free body diagram? You need to first remove these supports. Remove the supports. Now if you remove the support, then you need to apply the reactions, proper reactions. If you remove the roller support, you will have to apply a reaction normal to the surface of roller. So this is the surface of roller, na? So the force, the reaction force must be normal to it. It can be in plus y or minus y direction. It is up to you. So I will assume that the reaction force at A is upward. Let me call it RA. Now at point B we have a hinge support. So if you remove the hinge support, you will have to use two reactions. One like this, one like this. I will call it RBX. I will call it RBY. Now you can see this is the free body diagram of the plate. What is this? This is free body diagram, also known as FBD. Okay. So we have isolated the body from all the other bodies. Now how many unknowns do you see here? You see three unknowns: RA, RBX and RBY. And how many equilibrium equations do you have? You have three equilibrium equations. You can use all these three equilibrium equations and you can find these unknown forces. Let me use the third equation first. I will apply the moment equation first. Now where I will take moment? You can take moment about any point. You can take moment about any point inside or outside the body, doesn't matter. But here I will take moment at B. Why I will take moment at B? Because if I take moment at B, the moment of RBX and RBY will be 0. I will get the moment of RA, this 400 Newton, this 500 Newton. So there will be only one unknown in the equation RA. So I will get the value of RA. So I will apply this equation. Net moment at point B equal to 0. You can take moment about any point. Net moment about any point must be 0. But if you take moment about B, you will have the advantage of getting the moment of RBX and RBY 0. So net moment at point B equal to 0. The moment of RBX and RBY will be 0 because they are acting at B. Moment of RA will be clockwise. What will be the moment? RA into 20. It will be clockwise. Now moment of this 400 Newton will also be clockwise. Moment of this 400 Newton will also be clockwise. Plus 400 into 10. But the moment of this 500 Newton will be anti-clockwise. So minus 500 multiplied by, this will be 16. So from here, I will get the value of RA. There is only one unknown. See? So 500 into 16 minus 400 into 10. 4000 divided by 20. So I am getting RA equal to 200 Newton. So I have got RA 200 Newton. Now I will calculate RBX by applying the second equilibrium equation. So I will apply first equilibrium equation. Summation of Fx equals to 0. So you can see that in X direction you have two forces, 400 and RBX. So I can write this RBX equal to 400 Newton. Because both must be equal and opposite, na? Then only net force in X will be 0. So RBX will be equal to 400 Newton. Now how do we calculate RBY? Summation of Fy equal to 0. So I will get RA plus RBY equal to 500 Newton. And RA is how much? 200 Newton. So 200 plus RBY equal to 500 Newton. So RBY will be equal to 300 Newton. So I have got RBY also. Now if you want, you can take the resultant of RBX and RBY. Now although it is not clear in this question whether you need to find components of RB or the resultant of RBX and RBY, let's calculate the resultant. In GATE they will tell you whether you need to find the components or you need to find the resultant. Okay, here I have not mentioned. So it will be 400 square plus 300 square. So RB will be 500 Newton, right? Very good, Sanjay, very good. RB is 500 Newton and RA is 200 Newton. Okay. So understand the procedure. First, I isolated the body from the supports. Then I applied the reactions. Then I applied the equilibrium equation, solved the equation, found the values. Now look at the values. All the values I am getting are positive. Means my directions were correct. Let's say you are assuming RBX to be like this. Then here you will get minus 400. Means your direction is wrong. Chalo, let's solve another question. Solve this one. This is an interesting one. The homogeneous triangular plate of weight 1000 Newton is supported by a pin at A and a roller at C. Find the reactions at A and C. So we have a triangular plate which is hinged at A and there is a roller at C. The plate has a weight of 1000 Newton. It is homogeneous means the weight is equally distributed. It means we can assume the weight to be acting at the centroid of this plate. Okay. Now I have to draw the FBD of this plate. So look at the FBD. The plate is something like this. This is A, this is B, this is C. Now, where will be the centroid of the triangular plate? Centroid of the triangular plate will be somewhere here, okay? L by 3 from here and 2L by 3 from here. If you don't know about centroid, don't worry. I will take a special class. I will take a lecture on centroid also. Okay, so don't worry about it. So this will be 0.6 by 3 and this will be 2 into 0.6 by 3. Okay, so the weight of 1000 Newton will be acting here. Chalo. Now, there is a roller support at C. So the reaction at the roller will be normal to the surface like this. Now understand this very important thing. This surface is making 30° with horizontal. This is the surface and it is making 30° with horizontal. So the reaction which is normal to the surface, the reaction will be normal to the surface, it will make 60° with horizontal. The surface is making 30° with horizontal, so the reaction which is normal to this surface will make 60°, 90 minus 30, 60° with horizontal. So this angle will be 60°. Okay, normal to the surface. Surface was making 30 with horizontal, so the reaction is making 60 with horizontal. Okay, now at point A, you will have two reactions. One is, let's say, like this, another one is, let's say, like this. This is just my assumption. Okay, I don't know whether the X Wallah direct reaction will be in this direction or this direction. I have just assumed it. So RAX, RAY. Now how many unknown do we have? Again we have three unknowns, RAX, RAY and RC. So again we have three equilibrium equations. Now which equilibrium equation are we going to use first? Let's take moment at A and calculate RC. Let's take moment at A and calculate RC. Okay. Now if I take moment at A, moment of RAX and RAY will be gone. Moment of RAX and RAY will be gone. I will have to calculate the moment of RC and this 1000 Newton. Now RC is inclined. So what you can do is you can resolve RC into two components. Okay. You can resolve RC into two components, or what you can do is, let's calculate this. This angle is 30°, almost 30°. Means this RC is normal to this surface also, but it will be confusing for you. There will be too many questions. Those who have understood it, let me tell you this, that RC is also normal to this surface. This surface and this surface are parallel to each other, it seems, because this angle is almost equal to 30°. So the reaction is also normal to this surface. So you know the perpendicular distance of RC from A. It will be equal to this distance. So you can directly calculate moment of RC. RC multiplied by this distance. Okay. But if you are not able to get that, don't worry, just resolve RC into two components. This will be RC sin 60, this will be RC cos 60, right? So now we can take moment at point A. So moment at point A must be 0. Now moment of RC sin 60 and RC cos 60 both will be anti-clockwise at point A. So RC sin 60 multiplied by this distance. How much is this distance? 0.6 plus RC cos 60 multiplied by this distance. How much is this? 0.35. Both these moments are anti-clockwise, but moment of 1000 will be clockwise. So it will be minus 1000 into 0.6 by 3, L by 3. So from here you will get the value of RC. So it will be 200 divided by 0.6 sin 60 plus 0.35 cos 60. I am getting 287.93 Newton. 287.93 Newton. I hope you also are getting the same. 287.93 Newton. Now we can find out RAX and RAY. So if I apply summation of Fx equals to 0, RAX is towards right and RC cos 60 is towards left. So it will be RAX equals to RC cos 60, means RAX will be equal to RC, which is how much? 287.93 cos 60. So RAX will be 143.96. 143.96 Newton. Very good. Now summation of Fy equal to 0. So if I apply summation of Fy equal to 0, in y direction you have Ray, RC sin 60 and 1000. So it will be Ray plus RC sin 60. Both are upward and 1000 is downward. So Ray plus 287.93 sin 60 equal to 1000. So from here you get Ray. So 1000 minus 287.93 sin 60. I am getting 750.64. 750.64 Newton. 750.64 Newton. So these are the values of RC, RAX and RAY. I hope this is clear to you. Let's move on to the next question. Now this is an interesting one. This is an MSQ question. What do we mean by MSQ question? In GATE you have three types of question. NAT, which is numerical answer type, where you have these blank spaces and you have to fill the answers. Okay. Then MCQ, multiple choice question, where you have 4 options and one of the option is correct. And then MSQ, multiple select question, where you have multiple options which can be correct. 4 options are there, na? So maybe there is only one correct answer, maybe there are 2 correct answers, maybe there are 3 correct answers, maybe there are 4 correct answers. But here is a catch. In these type of questions, let's say there are 3 correct answers, but you have given only 1 or 2. There are 3, but you have given only 1 or 2. You will not get any marks. You will get 0 marks. There will be no negative mark in these type of questions. But if there are 3 correct answers, you have to give all 3 correct answers. Otherwise, you will get 0 marks. Okay. A 1000 Newton homogeneous smooth sphere rests on an inclined surface at A and against a smooth wall at B. Which one or more of the following statements is or are correct? Reaction at A is 433 Newton. Reaction at A is 566 Newton. Reaction at B is 283 Newton. And reaction at B is 133 Newton. So basically you need to calculate reaction at A and reaction at B. So how are we going to solve this problem? First you need to draw the free body diagram. Okay, you need to draw the free body diagram. So here, this sphere, it has a weight of 1000 Newton and it is homogeneous. Homogeneous means the weight is equally distributed. So the weight will be acting at the centroid. Centroid of the sphere will be at the center. Okay, so this is 1000 Newton. Now, at point A and B, we have frictionless surfaces. Okay, smooth surface bole to, smooth surface means frictionless surfaces. And in case of frictionless surfaces, you get the reaction normal to the surface. So at point B, the surface is vertical, so the reaction will be horizontal. So it will be RB. Similarly, at point A, the surface is inclined, so reaction will also be inclined. How? What will be the angle? The angle will be, see, the surface is making 30 with horizontal. So the normal of surface will make 60 with horizontal. Okay. This angle is normal 90 degree. This angle is 90 degree. So the surface is making 30 with horizontal. The reaction will make 60 with horizontal. Okay. Now, how many forces do we have? We have 3 forces. So these 3 must be either parallel or concurrent. They don't seem parallel. It means they must be concurrent. Okay. And in this case, you can apply Lamys theorem. You can apply Lamys theorem. Okay. Now, either all 3 forces must be acting towards the center or away from the center. So here all 3 forces are acting towards the center, na? So I can calculate the angles from this diagram. What will be this angle, beta? It will be 90 degree. Right? What will be this angle? What will be this angle? See. This is 90, this is 60, so this is 30, right? Let me draw this and let me divide the angle into 2. This is 30 and this is 90. So the total angle is 120. Okay, now what will be this angle? Now you can easily calculate this, na? 90, 90, 180, 180 plus 30, 210. This will be 150. Okay. Now I can apply Lamys theorem. So according to Lamys theorem, RA divided by sine of angle between RB and 1000 is 90. equals to 1000 divided by sine of angle between RA and RB is 120 equal to RB divided by sine of angle between 1000 and RA is 150. So from here I can find the value of RA as well as RB. So what will be RA? 1000 into sine 90 divided by sine 120. Sine 90 is 1. So it will be 1000 divided by sine 120. Am I correct? So here I am getting 1154.7. Are you also getting this 1154.7? $288.67. So I am getting these answers. It means none of the options are correct. Let's change the options, okay? Let's change the options. So RA is 1154.7. Let me make it 1155. And RB is 288. So let me make it 289. Okay. So now B and D are correct. Okay. So there was some mistake with the question, but I have corrected the mistake. 1155, 289. So I hope this is clear. Let me check again if I am getting the correct thing. There must be some value which was wrong. That's why we are not getting the correct answer. So I have changed the question itself. This is 577.35 na? $577.35, right? 1000 into sine 150 divided by sine 120, 577.35, right? Sorry, so 578. Okay. Now this is your assignment question. It is very similar to the last question. So I want you to solve this question on your own, and in the next class we will see what is the answer, the correct answer. Okay, now the next class will be on Monday. Okay, next class will be on Monday at the same time. So I will see you guys on Monday, same time. Till then, thank you so much for watching the lecture. Bye bye, take care, good night.